Good morning, good afternoon, and good evening, everyone. Welcome to this webinar. It's titled Smart Metering Around the World. My name is Elaine Reinke. I work at the Development Impact Measurement Department at the International Finance Corporation, and I recently took over the role of the research lead of the MAGC program, which is short for Market Accelerator for Green Construction program. That's financed and implemented in partnership with the UK government, specifically the Department for Energy Security and Net Zero. It seeks to accelerate green building designs and technologies in developing and emerging markets through coordinated efforts within different departments in IFC. That includes the Climate Department, the EDGE team, which is short for Excellence in Design for Greater Efficiency, which you'll hear more about in a minute. The Financial Institutions Group. It also includes the Blended Finance Department and Development. This 90-minute webinar will now provide an update on the different pieces of research that are conducted under the MAGC Research Program, which is a small but integral part of the entire MAGC program. Before we get started, I'd like to briefly introduce the MAGC Research partners and the speakers and have a look at the agenda for today. So I'm trying to move the slides. Okay, perfect. So here we see the MAGC partners, as I already mentioned. The UK government is our key donor and partner for this program. Two important pieces of research that we'd like to talk about today are the smart metering studies in South Africa, Colombia, and Indonesia, and embodied carbon study. So for the smart metering studies, we're partnering with the University College in London as the central research team. In South Africa, the local research team is the University of Cape Town. In Colombia, we're working with Miyamoto International. And for the study in Indonesia, with the University of New South Wales in Australia and Universitas Trisakti in Jakarta. And last but not least, for the global consultancy firm Arup, we are partnering with them. So it's great to see that we have lined up a really good group of speakers for today. So Simon Elam and Martin Pullinger are our experts from the University College London who will present the overall research design of the smart meter impact evaluations in South Africa. Grant Smith from the University of Cape Town will then provide an overview of the pilot phase of the smart metering study in South Africa and provide an outlook for the plan for the meetings. Maria Carrizosa and Clara will present on the smart metering study in Colombia. Then Eoghan McKenna, together with a local research partner, Eoghan Bhakti, will present on the Indonesia study. And last but not least, Matthew Monroe from Arup will provide insights on the ongoing study. With that, I've pretty much already walked us through the agenda. The screen shortly. So, I would like to ask that we have planned 15 to 20 minutes for Q&A, that you please post your questions and comment chat. I'll try my best to monitor them, and then we'll address them to us at the end of the session. And for now, without further ado, I'd like to welcome Monica Poletti for some opening remarks from the UK government and the Department for Energy Security and Net Zero. So let me stop sharing my screen, and I hope that, Monica, you can come with some opening remarks. Thank you. I'm not sure if we have Monica on the line. Monica, can you hear us? If we cannot are on the line, I would say we'll get started with Simon and Martin from the Central Research Team. University.
Monica's just posted in the chat that she's here, but she can't unmute herself.
Oh, Monica, you're here. Can you unmute and start speaking?
Yeah, she's having problems unmuting herself by the look of things. Do you maybe
working? Simon, can you try and speak?
Can you hear me?
Yes, we can.
Yeah. Oh. Okay. Yeah, Monica, your camera also is, I can't see you either. Should we start perhaps with the UCL presentation and then come back to Monica if the technical issues get resolved? Okay, I'm gonna hope that I have some success in. Okay, so can everyone hear me? Can I just check? Yeah, okay, great, thank you. So as Elaine was saying, we have the role, University College London, the Smart Energy Research Group at University College London, we have the role of the Central Research Team. We're a research group that primarily conducts data-driven research, investigating the drivers of energy demand in residential buildings. The team you can see there, there's only about 4 of us actually working on this research project. Sorry, wrong way. So a little bit of context about how we use smart meter data for research and evaluation purposes. So we've created the Smart Energy Research Lab Observatory, which is 13,000 homes across Great Britain, where we collect and manage smart meter data and link it to relevant contextual data. And so in doing that, we've developed and refined methods for processing smart metering data, as well as for analysis. And those analytical techniques, we've got statistical techniques such as regression and cluster analysis. We've got some more advanced and quite well-refined machine learning techniques. And we also, to a slightly lesser extent, use some kind of building physics analysis as well. And the type of research that we do with that, it's obviously relevant to this project, is evaluating building performance. We also use this data and our analysis for identifying energy poverty, for investigating energy demand profiles, and for informing government policy. And just a kind of example of the graph that you see down on the bottom right of the slide there. This is kind of relevant at least to one part of the EDGE evaluation study. So this was a paper that demonstrates energy performance certificates, which are the kind of energy efficiency rating for buildings in the UK. This shows that the modeled energy consumption from the EPCs actually over predicts energy use in the least energy efficient properties, and that increasingly over predicts the change between bands. And that's relevant for the part of the study that we're doing in this evaluation, where we'll be looking at the EDGE modeled energy consumption and comparing that to actual modeled energy consumption. Sorry, actual energy consumption. Okay, and our evaluation, our role on this EDGE evaluation project as the Central Research Team. So we're responsible for the overall research design. We'll be conducting a lot of the quantitative analysis when we get the data that's been collected by the various in-country teams. And we will be writing, essentially responsible for producing a lot of the central research reports and midland reports and final reports. And how we engage with our project partners in the 3 countries. So we don't manage the work of the in-country teams, but we do have regular and ongoing engagement with the in-country teams pretty much on a weekly basis. And we do that to ensure consistency and understand the differences across the study countries. So as an example, domestic hot water is key to EDGE savings in South Africa, but largely irrelevant in Indonesia. So we have to kind of understand these differences in the various study countries so that we can optimize the adaptation of the central research design into effective country-specific study manuals. Okay, and at that point, I will hand over to my colleague Martin, who has been leading on the research design and who's going to talk you through that.
Okay, thanks, Simon. So yeah, I'm Martin Pullinger. I'm one of the senior researchers at UCL that's working on as a central part of the central research team on this evaluation. Over the next 7 or 8 minutes, I'm going to give you a very high-level overview of the EDGE impact evaluation study. Just before I start, I'm going to give a little context to the study. Most of the audience is likely to be familiar with EDGE, but in case you're not, it's a green building certification scheme that's managed by the IFC. It covers a range of building types, including residential, which is the focus of this particular study. There's well over 1.5 million residences that have been certified to date in emerging markets around the world. So it's a well-used standard. And there's 3 main components to it. The first is a software tool, a web app that developers can use to test out their green building designs. So they can input their site design and they can experiment with different green building solutions to identify how much in-use energy and water they'd be predicted to save and how much embodied energy in the building materials they would save. And if they develop a design that saves 20% in terms of in-use energy and water and embodied energy, then they meet the EDGE building standards and they can get their site verified and certified as an EDGE site. And that can unlock different benefits for the developer, such as preferential loan interest rates, as well as potentially for the eventual buyer. So here's an example of what the EDGE software tool looks like. The graph you can see here gives an example of the kind of output it produces. In this case, it's for in-use energy intensity. So it produces an estimate of annual energy and water intensity for the development. That's overall, and it's also broken down by major end uses, so things like space heating and cooling, hot water energy demand, and so on. And it will produce an estimate as well of the percentage savings compared to a local equivalent conventional building. So one that's built to the local building standards or conventions. And that's how the 20% savings are defined against this local building standard. So if you select different EDGE solutions from the list on the left of the screen of the display, it will update the predicted energy demand for your design that is shown in the graph on the right. So onto the study design. The study is aiming to evaluate the performance of EDGE certified residential buildings on the ground, so actually in use by actual residents. The scope covers the in-use energy and water demand, but it's not the embodied energy use and materials. And as these 3 study countries involve South Africa, Colombia, and Indonesia. We have a set of defined research questions that we aim to address in the study that are presented here. In essence, these are about evaluating the extent to which EDGE-certified residential buildings save as much energy and water as they're predicted to by the EDGE software tool, and also compared to other equivalent buildings built to local building standards. So as well as that kind of high-level result, we'll dig deeper behind that to look at whether this varies by building type and also over time. So are there seasonal variations in how well buildings perform, for example? And we'll also focus on some particular green solutions to see if they're performing better than others in use. And we'll look at the main reasons behind any performance gaps that we identify. And the aim from all that is that it will provide us with insights into ways in which the EDGE software could be improved to increase the accuracy of its predictions, and also ways in which actual savings for buildings on the ground could be improved. So there's three main components to the study. First of all, is site selection. This is about identifying suitable EDGE residential sites and then matched counterfactual sites, so like a control group of sites. And we'll be collecting data from residences in both sets of sites. So in terms of the EDGE sites, we're looking for a selection of sites that cover the main urban locations that you find EDGE buildings in the study countries, and also a good range of the main EDGE solutions that are in use in those countries, and across a range of income bands as well for the occupants. In terms of the counterfactual sites, we want sites that are matched to the EDGE sites in terms of their location and income band and the type of building, but that are built close to the local base case building standards. And once we've got our sites selected, the next stage is data collection. So kind of the headline data that we want is the energy and water meter data. We're going to be collecting that for some thousands of households in each country. Where possible, we'll be using smart meter data. Where it's not possible because there aren't smart meters installed, we'll be resorting to monthly manual readings. To understand the patterns of energy and water use that we see from that data, we're going to be collecting a lot of contextual data as well. So there'll be a participant survey where we get things like the demographics, so the characteristics of the occupants in the properties, the building and appliance characteristics, and the energy and water using behaviours. We'll collect data from EDGE reports and site inspections to give us more detailed information about the building types and the energy saving technologies that are in place. We'll also link all that to weather data because that's one of the main drivers of energy use in many cases. For a smaller set of homes, numbering in a few hundreds, we'll collect texture sensor data as well to monitor indoor temperature and humidity. So that will give us some insight into the achieved outcomes in the properties. And also in some cases, we'll be collecting energy and water use data for just particular end uses that reflect particular green solutions. So as Simon was mentioning, in South Africa, hot water electricity consumption is kind of a key one, just as an example. Then the final stage, obviously, once you've got the data, we'll be doing some data analysis. There'll be some main stages to that, comparing the measured energy and water use between the EDGE sites and the counterfactual sites, comparing the measured energy and water use with the actual EDGE predictions for those sites as well. And then we'll investigate variations in those results by region and over time and for the main EDGE solutions that are in use, and try to identify any factors that explain any observed performance gaps. And the aim, as I said, is to give insights for the EDGE software and program design, potential improvements that could be made in future. Just as the last stage, we've structured this as a two-stage study design. So there's a pilot phase that involves adapting the study design to each country. It's about learning, preparing for the main phase rather than trying to answer the research questions. So it's about trialing the different aspects of the study, identifying suitable sites, testing monitoring equipment and surveys. It's also about engaging with developers and site managers as part of just engaging with stakeholders and getting access to the sites. Quite small numbers of participants as a result. So the 3 study countries are just about at the end of that phase, or they've just completed it. We're going to be moving into the main phase very soon. So that will run from around now until the end of 2026. And that's about the full implementation of the study, recruitment, data collection, data analysis, and obviously reporting results. So I'm going to stop there. There's time for questions at the end. For now, I'm going to hand over to the teams that are leading the evaluation in each of the 3 study countries, starting with Grant, who's leading the South Africa team.
Hello, everybody. Let me make this. I believe you should be able to see my presentation now very well. So I'm Grant Smith. I'm leading the South African study, and I'm working primarily with two senior colleagues. I'm an economist by training, but I'm working with two engineers, Richard Lamore, who's an electrical engineer, and Alison Hughes, who's a mechanical engineer and residential expert. We are based at the Energy Systems Research Group, and as Simon and Martin said, that's at the University of Cape Town. So I'll take you through the South African context. Well, through the South African pilot, I'll just give you a quick context to South Africa. I'll take you through the pilot phase, which was run mainly in 2023. And then I'll talk you through where we are on the main phase. All right, South Africa. We actually have quite a lot of Edge stock at the moment. Edge has been active here for just over 10 years. It's almost entirely residential apartments, concentrated primarily in Gauteng, Cape Town, and eThekwini and surrounding areas. And don't worry if you don't know where those are, there's a map for you very soon. Our local building standard, which is the most relevant, most appropriate proxy for the base case, has a very high efficiency standard already. For example, 50% of all energy that's used in hot water production needs to come from renewable resources. So it is already a fairly efficient building standard. In South Africa, supply interruptions for utilities are a factor for the last decade, but especially the last 5 years. Load shedding, which is a term that in fact originated in the UK in the 1950s, but that refers to planned grid electricity outages at different sort of segments of the grid, has been a reality up until March 2024 and largely has waned since then. But in our historical data, that will be a factor affecting consumption readings of grid electricity. And it also drives the appliance stock that households will have accumulated. So in particular, alternatives to grid electric powered appliances. Increasingly, in and around Gauteng and to a less degree in and around eThekwini, water shedding has become a factor, and that's these planned and unplanned large-scale water outages. So that has really been emerging in the last year and a half, and in Gauteng especially. So that will influence our consumption readings on water. Just to give a broader context, the South African National Electric Grid is still quite coal intensive. Roughly 80% of our generation is coal based. So standards like Edge can have a material impact compared to in terms of coal CO2 equivalent. All right, let's talk through the pilot phase. So as Martin mentioned, the purpose of the pilot phase was to just test all our different data gathering methods. And in simplicity, there's three major parts to this. First, the backbone of the study is what the data we get from smart meters. These are electricity meters reporting mainly 30 minutes to 6 hour intervals, water meters, which are overwhelmingly 6 hour intervals, data, and that gives us the backbone of what would be the study. So we piloted how to get those different sorts of meters, different sorts of setups with suppliers, and so on. We then had a household survey, a panel survey. Again, this was not meant to be representative. We were just trying to see where the gremlins were and how to deal with them. So we anticipated that we'd like to run a two-wave panel in the main phase. And so we did a very short two-wave panel in 2023, June, August, September, October. And we had 131 in the first wave, 131 apartments, and 69 apartments in the second wave. We had a very low effort method to recontact. We basically just sent people an email, and we got about a 50% response rate, which was really great. Just to give you a quick breakdown of how that sample broke down, we had 47 non-edge apartments and 106 edge apartments. And again, it wasn't meant to represent the universe of non-edge and edge residential apartments, just to trial the different data collection methods. We also developed, we innovated and developed a hot water node with a third-party supplier and deployed air quality sensors. As Martin has highlighted, and as I'll chat to in a moment, hot water production is really material in South Africa, and the indoor air temperature, we can look at build performance. Okay, here's the map I promised. You will see that Cape Town is located on the southwest of the country. This is where I'm talking to you from. And it's a Mediterranean climate. So currently right now it's raining in winter, and it's sunny and dry in summer. In the middle to top to the northeast corner of that map is Gauteng. That's primarily the cities of Johannesburg and Pretoria and a few other towns. The largest sort of urban agglomeration in South Africa, and historically, and a lot of edge stock and non-edge stock is located there. They are an classic interior climate, dry but cold winters, with lots of intraday temperature variation, as you would expect in a landlocked place. They fall in the summer rainfall region. Finally, Durban, also now known as eThekwini, is on the middle and east parts of the map you're looking at. And that is more of a subtropical climate, rainfall in winter, dry in the summer, but quite moderate temperatures in winter, extremely humid. All right, so that is where our sample is, and in the pilot, as will be in the main phase, the bulk of the samples, in fact, in Gauteng and Cape Town. All right. As I've mentioned, the backbone, both of the pilot and in the main phase, will be smart metering data. There are a host of different types of smart meters, but they all do essentially the same thing. And what we define as smart meters here is not so much the ability to remote control something, although many do have that property, but rather to report intraday consumption and to allow billing on that basis, active billing, which we'll get to in a moment. There's a photo of one of the common setups you'll see. And you've got some water meters and electricity meters in that. No, those are all water meters. There we go. All right, so what happens is that at a site, a third-party company will be contracted to collect metering data. In the pilot, we found it much more effective with the consent of the apartment block owner or developer, to go straight to that company and then use them as one sort of central port of call to collect all our data. And they'll meter usually for many sites, and so that there's an economies of scale there. The data are high fidelity, very few problematic readings, and so we enjoyed it. Largely they're cumulative as well. They reach back into history, so you could go 2-4 years back once you get access. So that's very advantageous. We did include some sites that only had manually read meters, because we wanted to see, well, what would happen if we did that, how feasible, what would it be like to deal with that data in this context. And essentially we found that it was not, the sites that had that type of metering were a lot older than on average than the edge stock. So it was doubtful that they were good comparison sites. And they're also very difficult to get useful consumption data that we could compare to the edge sites. Finally, most of the sites, both edge and the comparison sites, the tenants pay for their consumption, their water and energy consumption, as well as other things in their apartment through an electronic wallet or e-wallet. And this is done on a prepaid, pay-ahead basis or prepaid basis. So the tenants load up a balance, and then that balance, these smart meters will report through the metering company what the consumption is over the half-hour period, and or whatever the period is, and then your balance will decline by that much until it reaches to zero. Then you cannot consume energy. Water is a constitutionally protected right in South Africa, and it's been decided that it is usually at the equivalent rate of 6 kiloliters per household per month. So if your balance goes to zero, as one of our tenants, you won't get grid energy or metered energy, but you would get water, but at a much lower flow rate. Wrong button. Domestic hot water is both in our national building standard and an EDGE considered to be a very important part of, or assumed to be a very important part of residential energy consumption. And there are a host of different ways of producing domestic hot water as a result. Here are some photographs. You have very clever, almost AI-driven solutions. It's a hot box, one of the technologies out there. You can also have a solar water heater, which is literally direct heating by the sun of a water canister. You would also have PV panels supplying energy to the mini grid within the development, and then your water heater would draw from that mini grid. You would also have direct PV to geyser systems. This, by the way, is a geyser. That's what we call water heaters in South Africa. And you'll see this cladding on the water pipes. That's a result of our national building standard. All right, let me keep moving. This slide, this presentation, by the way, could easily have been over 100 slides, but we're over halfway. You'll be pleased to know. There are a host of different hot water systems. You could have classic single element powered by PV, or it could be 2 elements. Be grid tied PV. That's when your solar panels power a mini grid in the development. You could also combine that or substitute it with unit level heat pumps. You can combine it with heat pumps. You could have a centralized hot water production with heat pumps or with solar, as we discovered. And you could also have solar water heaters as backup. And then in the minority, there are these very interesting inline element heaters where water rushes through and makes contact with the element. But they're quite small and usually under a bit of pressure. All right, here's just a few results. There's a lot of results from the pilot. I'll just give you a sense of what the more important ones were from our pilot. So what we're looking at is monthly consumption for a year period, and with a quadratic equation is the best fit and 95% confidence intervals. The non-edge units are on the left-hand side and the edge is on the right-hand side. And while this is nowhere near large enough sample to be able to pronounce whether edge in fact delivers a 20% reduction in terms of this, we're looking at grid energy consumption. In the pilot, the indication is certainly consistent with that claim. I mean, just to stress, because I know that slides can get a life of their own, this is not a large enough sample to adjudicate the benefits of edge, or whether it can deliver those savings or not. But it is indicative in our pilot that probably it's there. From our household survey, there were just, apart from the useful demographics and the socioeconomics, which serve as useful controls and household size, that sort of thing, 1 or 2 findings did emerge in an unexpected fashion, which is to say that this is even among this formerly housed population, which we don't generally think of as being subject to poverty, there were signs of severe affordability constraints that would influence consumption among a minority. In particular, 10 households at least said that they had gone without electricity because they had run out of money for 1 day of the month at least, and a few more for longer. So that we know that in the main phase, we have to look to these affordability constraints, even among this formerly housed population. A lot of people still used gas. These are personal, individual gas bottles that they would use to power a hob or such to cook. And obviously that would be energy that's used, but it's not metered. So we needed to find a solution there. And there are also behavioral issues. There are a lot of ways of using this green technology in different places, but this is a slide which says, well, essentially many people are not using those control systems. So the main insights, smart meter data, it's really available. It's high fidelity. We could ingest it at scale. The manual meter reading was just too much trouble, and the sites were probably not, they were just a little bit older than the edge sites anyway, so a bad comparison. So we're in the main phase, we're going to lean on smart meter data. The household survey, key to success is getting responses. The best strategy we found was actually invite either under or on the door. You have to get the manager on the site to buy into this program, and they will informally advocate for and raise awareness, as well as trust, letting people know this is not a scam, and to precede this with a general communication, which won't raise your response rate, but will start to build trust that this is your survey is not a scam. All right, I've gone through the other things. Additional sensors. We had a long development period here. A lot of things can go wrong. So we found we had to cleave to this evolution of a bench test, so a laboratory test, then a limited field test, and then you roll out. All right, time is racing. And let me move to the last few slides. So we're in our main phase right now. We're looking at the research questions that Martin took us through. Essentially, what are the savings? How do they vary with variables of interest? And is there anything that we can discover about what can be done to increase the accuracy of predicted savings as well as actual savings? Setup has been long for three main reasons. First, we had to obviously vastly expand our universe. We now have about 9 partners, and we had to build those relationships, understand their systems, get them to trust us. But we have 9 very large developers who are on board now. We had to visit their sites, or at least a big enough sample of their sites to make sure we understood what was going on. So that's done as well now. And then we had to comply with our national data privacy, data protection laws. This is a long data sharing agreement to document, and this has taken months. Not because developers don't want to sign them. It's just we're dealing usually with the CEO or one down from the CEO, and getting their attention is the tricky part. But we have 7 or maybe 8 now out of these things signed. And so we have more than enough to proceed, and the last one can come on when they're ready. Securing sufficient computing and storage resources that's not too difficult for us. We have a well-developed, built-out infrastructure in the University of Cape Town, because there will be a lot of data. And worthwhile mentioning, this will be the largest and most rigorous study of residential apartments and their energy and water consumption in South Africa ever, so far as we know. All right, so our main study design, we have 58,000 apartments spread over 104 sites, and we're ingesting their metering data and related data. So these would be edge inputs, floor area, window to wall ratio, all of those good things. And that's the foundation of the main phase analysis will be based on this big data. In a sample of about just over 5,800 apartments spread over 68 sites, we'll conduct another 2-wave survey in mid-2025, so but maybe in a month's time from now, and the same next year, looking at household characteristics and so on. Then, for reasons we've kind of gone through already, in a minority of 900 apartments, we will deploy additional sensors, these specialized sensors to measure hot water production, indoor air temperature and humidity, to see built performance. And we also have a solution, or a third party has a solution for apartment level, monitoring apartment level gas bottle usage, which is an important energy substitute to grid or solar. This is the final slide. This is a lot of data. So we combine it all by ingesting it onto our supercomputing infrastructure, which we call the High Performance Computing Center. In each case, a copy of raw data is saved on a specialized long-term storage section. The copy of the raw data is then cleaned and harmonized because it arrives from different providers with different formats. So we harmonize that as part of the cleaning. That cleaned data is then, a copy of that is then stored in addition. And then we go through a combination exercise. This is either to combine all the metering data together, or the survey and metering data, or the additional sensor survey and metering data. And that is again stored on storage, and then we are analysis ready, which is where we are. Okay, that is an overview of South Africa. I'll stop sharing. And as Martin said, there's time for questions at the end. But now I think I hand over to, is it to you, Elaine? Oh, Maria, I hand over to you, Maria.
Thank you, Grant. Let me just share my screen here. Can everybody hear me and see my screen, or not yet?
Yes.
Okay, perfect. So my name is Maria Carrizosa. I represent Miyamoto International, and I am the project coordinator for the study that is being run in Colombia. With me, I mean, we have a big team, but today we also have Clara, who's going to be sharing her view, you know, from the side of the developer, which it's been very, you know, their inputs have been very important during the whole process. Our team is basically built up of a joint effort of 3 companies, ourselves, Miyamoto, who are leading and coordinating and doing all the technical leading of the project. Then we have Green Loop, who is a leading company in a green certification in Colombia. So they have a really good amount of partners and developers that they've been working during, you know, in their normal practice. And Data Plus, who have been really essential for all the groundwork that we've been advancing, especially, you know, all the surveying, the site inspections, all the participant recruitment has been led by them. That's sort of like their daily expertise. And, you know, through this partnership, we've been able to at this point, we're finishing up the pilot. So we're behind Grant and his team. And so, you know, your insights have been actually being very useful. We're going to be looking today at also some particularities of the Colombian housing production. Then we'll share with you the protocols that we've tested and some of the lessons learned. And we're going to hear from Clara about sort of like the point of view of the developer and the efforts that they're doing also internally to understand better how to use the Edge tool and how to increase efficiency in terms of savings. So our project objectives are, of course, to conduct an assessment of the performance of existing Edge certified residential buildings in Colombia, where we are assessing the actual energy savings achieved by the Edge certified projects compared to conventional or non-certified projects. And we are also reviewing the performance of the Edge energy saving prediction algorithm by comparing the predicted energy consumption results with actual on-site measurements. So let's just get started with Colombian housing production. So most of our Edge product, the Edge certified projects in Colombia are Edge products, are social housing. That's what you see in this slide as VIP, VIS, and VISRU. That means, yeah, like social interest housing. And all of them, all the VIS and VIP housing runs around 40 to 48 square meters. and they are delivered without finishes. So that is key for the edge tool, because you know, some of the elements that can be controlled based on the finishes, you know, are not part of the social housing production. Then we have also what we call here housing solutions, which is mostly for like dorms or special housing, hotels, short-term rents, etc. And then market rate size housing, which, you know, varies in terms of area, etc. The way that we produce that that housing is mostly through private initiatives. There's also a lot of public-private partnerships, especially in new areas of development. And we have a 16% of the housing production is based on self-built construction. So that is also something that you know, we've been also internally discussing on how you know, how to tackle this bigger production of housing in terms of green and sustainable solutions. As Grant was mentioning, one of the key stakeholders are building managers. This is like a big sort of stakeholder within our studies. As long as we have their support, we basically can have most of the data that we require. They are key for building trust, but they are also key for assuring access. And that has been sort of like one of the biggest challenges throughout the process. Basically building those relationships of trust and assuring that we can have them throughout the study. Because one of the other issues that we've been handling with is the fact that building administrations change. Every year they might change, so we have to rebuild that trust. In terms of the pilot, so as I was mentioning, most of the EDGE projects are social housing projects. We have a typical typology of social housing in Colombia is high-rise, so mostly more than 6 stories. They are delivered without finishes. We know that most of the currently certified projects are under version 2.1.5. And Bogota, Cali, and Medellin, which are 3 cities in different sort of climatic conditions, represent more than 90% of EDGE, and Bogota actually is the one that contains most of the amount of EDGE certified buildings, with 50% in total. Features of EDGE certified projects that we can see throughout are improved window to wall ratio and solar shading, water efficient fixtures that we already have national production of these types of fixtures, systems, and LED lighting provided. So typically, social housing is not, you know, the developer does not give the lighting fixtures, but in the case of EDGE projects, that has been like a big change in terms of that they do provide all the LED lighting for the projects that they sell. So this is sort of like a summary of the study design. Of course, we have the project ID, then we do site inspection, and in parallel, we're trying to do the EDGE remodeling. We do the baseline survey, which is that survey that is characterizing all the units in terms of like the socioeconomic composition of the unit. Then we would be doing a monthly data collection, quality control, and data transfer. This is still being piloted. Then we will have an endline survey. So these 3 last pieces of the study did not get piloted, but it will be part of our protocol. So the endline survey wants to sort of make sure that the socioeconomic condition of the household did not change, or if it did, then, you know, give a sort of like explain why the data is changing, if it is. We would be then later doing the analysis, and finally closing up with some feedback sessions with both the developers, but also we're still defining the type of feedback that we're going to be giving back to the buildings. So for the pilot phase, we included a subset of 100 housing units. distributed in Bogota, which is at 2,600 meters above sea level, Medellin, that is at 1,500 meters above sea level, and Cali, which is at 1,000 meters above sea level. So trying to get some sort of variability to test during the pilot phase. We did have a distribution between also edge and non-edge projects, having most of them being edge projects. And I mean, for the initial identification of the sample, the work with the developers was key. In that regard, the way that we work with developers is that first, as Grant was mentioning, we had a couple of interviews trying to create that partnership, and some of them, as Con Altura, who Clara is representing, have a lot of interest in having an active part. Some others are interested, but they just don't have the time or availability of experts to support that. But how we partnered with them was basically offering them first a first indication of the edge projects that they already have. Then we asked them to pair them with another project of their own. Basically, the way that we did it was dividing it into these two different criteria, so the determinant and the conditioning criteria. We wanted the paired project to be in the same city, to be the same socioeconomic characteristics, so basically social housing or market rate housing, to have the same housing unit areas, and same typology, so if it's a multi-story building or houses. And also trying to have them match the constructive system. Some of the conditioning criteria was basically, we were hoping to get also, for just logistical reasons, to have them in the same development, so same area of the city, and to have them in the same strata. All the Colombian cities are divided into geographic areas that pay different rates for utilities depending on where they are located and representing the socioeconomic composition of that specific area. And there is a huge variability in consumption depending on the strata where you live. So most of the time, people that are subsidized are, they may have a tendency to consume more in certain, certain certain utilities, and then people that are subsidizing pay a lot more. So the control over what they're expending might be a little bit more controlled. We also have, if we didn't have comparability in terms of the area, we're able to have a comparable area but the same number of bedrooms. The pairing strategy was used for the pilot and is being maintained for the main phase, but we are starting to find some challenges because some of the building managers of the older projects that are the non-certified projects, they have dropped out, and then we have less of a sample of non-paired projects, of non-edge projects. We did find a key sort of need for the project identification was to agree with the developers on a project replacement protocol, because a lot of the projects, even though we had them, once we go and do the site visits, for one reason or the other, they cannot be accessed. Mostly regarding that relationship with the developer, with the building administration, and sometimes they're just not interested in doing that next step. For the site inspection, we created these templates so that we could organize all the data regarding what was inspected, but mostly we were inspecting first if the utilities were reachable, so that we could just go and see the meters. Also, if the units were already occupied or not. And we found this phase critical for building that lasting relationship with the building administrations, which, as I've been mentioning, has been key for the whole project. The baseline survey, we've also had some lessons learned that have been adjusted for the main phase. So the first part is that we shortened the survey to avoid participant desertion. We had like a 25% desertion just because they were already tired of understanding of when we started describing the project. They were like not really interested in what we were doing, just wanted to respond to the survey. We also have been, it's been very challenging to recruit participants for the special monitoring. So we are including now that part in the baseline survey so that we can go through that recruitment in a parallel way to the general recruitment. And we found also the need to adjust the incentives so that we are also including incentives for the building administrators, given their importance during the whole process. Data collection, quality control, and data transfer. These are all things that are being tested at the moment, as well as the endline survey. We haven't piloted yet, but we do think it's key to include it to understand potential changes in consumption. Finally, regarding the additional monitoring equipment, which is something that we just started testing a couple of weeks ago, we found some key challenges during that installation. The first one is the location. Initially, we had envisioned installing the monitoring equipment on the meter rooms. Some building administrations were a little hesitant to do so. So we've had to shift our strategy. The participant recruitment has proven more challenging than initially anticipated. And also the installation of monitoring devices has had some requirements, like for example, anchoring to the wall, which might require, that will require repairs once we disinstall them. So if we were to install them in the meter rooms, that didn't seem to be a problem, but now we're installing them in a lot of different households, and that might increase the sort of scope of the work that we are dealing with right now. The same for the Wi-Fi. So initially we had one Wi-Fi transmitter per meter room, but now if the special metering equipment is going to be located in each household, then that might be sort of challenging. Access to information, so energy consumption readings should not be available for participants. We initially thought that would be an incentive, like, oh, we can show you how much you are consuming, but then we've realized that there might be interference in the behavior if we do so. So we're taking that out of the question. And the smart meters could provide insights on energy consumption by heavy home appliances, oven, fridge. So they have that capability, but it's been challenging regarding how to address this, because that requires active engagement from the residents to configure the devices. And so with that, I pass the microphone to Clara, who's going to be sharing some of her insights from the developer point of view.
Okay, thank you so much, Maria, for inviting us, and to all the organizers for having us, and for listening to a developer, because I think everyone who's participating in this webinar today has a common goal, which is to increase resource use efficiency. And I have brought a couple of ideas, opportunities, and challenges that as a developer we see to improve the whole system. And a lot of what you have mentioned so far, and a lot of what this study is working on, tackles many of those. So there are different actors within the system. Maria, if you could, I'll just tell you Dale, so you can click and we can see the different. Thank you. So we have a developer. Oh, and first of all, as a developer, just to quickly tell you, we have 35 years of experience building and developing housing projects. 99% of what we do is housing projects. We work both with social housing and market related housing. And we have nationwide presence. So what Maria was talking about, we have experience with. Now, when you're talking about resource efficiency, the efficiency in resource use, there's challenges when you confront a developer with the market. So first of all, the developer, at least in Colombia, is not going to operate the building. The building is going to be operated by individual families. So habits really play a role here, and trends can play a role as well, because we might deliver some fixtures and some faucets, but they might be able to, or they might want to change some of those either immediately or in a couple of years' time. So that's something that needs to be taken into account. Dale, Maria. Then there's another very important aspect to look into, and it is the relationship between like the regulation you have in each of the countries where you're developing the study, and in each of the countries where EDGE has a presence. In Colombia's case, they play to our favor because there are huge opportunities in Colombia because of the tax incentives and the technical incentives that are starting to be created by different municipalities around sustainable construction. So what that is doing is that is bringing more developers into the mix, and more developers are going to be able to sort of dig their toes into sustainable construction. Dale, porfa, Maria. When you look into the relationship between EDGE and local regulation, I think, or we think that there's a huge opportunity there to create better alignment between what the regulation is asking of developers and what developers are being able to measure in EDGE. So Martin was showing us earlier how you can see the savings according to the different strategies that you use in a project. You can measure the savings that you will have as compared to the EDGE baseline. It would be amazing to be able to look into that, but compared to the baseline of local regulation, because that would give us a control mechanism to ensure that we are complying with that regulation. Dale, Maria, por favor. And then when you look into the relationship between EDGE and the developer, this is something that has been very important and I think instrumental in bringing EDGE closer to our local reality. And those are the technical conversations that we have between the EDGE team and developers. Because of course, conditions between South Africa, Indonesia, Colombia are very different, and they're going to be very different in each country. So through those technical conversations, for example, we have been able to identify specific weather conditions that were not being taken into account. So a local airport was being used as a reference, and it was in fact a very different climatic condition to the ones the project was in. So that sort of fine detail. The relevance of passive strategies, which in countries where we don't have widespread heating and widespread air conditioning as part of our housing developments, those play a huge role. And those weren't really being factored in correctly previously on the EDGE app, but they are being factored in now. And then there are other conversations which are we're still having with them. For example, around the local energy matrix. We have a very clean energy matrix in Colombia. So it's 60 to 70% hydro electric power. And when in the Edge app, you say that you're going to use an electric water heater as opposed to a gas water heater, it shows less savings if you're using an electric water heater than a gas water heater. So that for our energy matrix does not make a lot of sense. So those types of conversations are very important. Then socioeconomic realities as well, because in lower income strata, it's common to find that people do not use hot water. But it is, I mean, the app is assuming that everyone does and that everyone can. And then finally, market preferences. So we are finding not only for social housing, like Maria stated earlier, but for regular market housing, we are finding that in some projects, in some areas, it is very attractive to offer a semi-finished apartment. So you will paint it, you will have part of the finishings, but you won't have any appliances or fixtures. So that is a challenge to prove that we will have the water savings if we're not going to deliver the faucets that are on the apartment. Dale, Maria. Por favor. And then for my final slides, I talked a little bit about the main stakeholders, but there are other very important stakeholders. Dale, por favor. So the financial sector is a huge player here. Also in Colombia's case, that plays to our advantage because there are financial incentives both for developers and for people who are buying sustainable housing. And there's a huge opportunity, I think, to find alternatives to loans. That's something that's not common here, but something that could be tapped into and maybe looked into. Dale, porfa. But there are also challenges around the financial sector. So one is calculating the impact of financial incentives. So mostly for our clients, they don't really understand the impact of the savings that they're having. So that's a huge one. And then the second one is developing technical incentives, the ones that are being developed by the municipalities. Dale, por favor. Another key stakeholder are suppliers, and there's lots of challenges around this. So one of them is efficiency versus design. I was talking about the trends earlier, and if suppliers have very limited availability of designs that are efficient, then it's going to increase the chances that the households are later going to change those just because of design trends. Another one is, and this is a huge one, efficiency versus comfort. So we might have a very water efficient faucet, but if that does not have the necessary conditions for the water heater to work, then people are going to change that because the people who use hot water are going to want hot water. So that's something that we have been struggling with. Another one is having them actually deliver their environmental product declarations, and that's huge for us to be able to really measure the embedded carbon and have an accurate measure of the embedded carbon. As well as technical specifications. Sometimes we struggle around getting the U value, getting the light transmittance. So if we don't get those, it's very difficult to prove or to work around that sustainable design. And then for my final point here, Dale Maria, por favor. Huge actor, the utilities companies. As a developer, we have been carrying out like our mini study for a couple of years now, where we go and we try to find information about how much water and energy the projects that we have certified are consuming during operation, but that has been a huge challenge. So accessing that consumption data is huge. This study is going to be great for us to learn and to actually get the information that we've been trying to work on to get for the past couple of years. A huge challenge is efficient resource use by users. Many people are not aware. Others just don't know how. Then another huge one is a market shift towards electrification. I think that's still far from being a market condition in Colombia. We still use a lot of gas, and we have to install gas as part of what we of the appliances that we deliver in our projects. So really shifting the market towards electrification is an opportunity. And then also having utilities companies decarbonize the energy mix. And a huge opportunity is, of course, smart meters. This is something in the case, I mean, for energy, it's something that is becoming more common in Colombia, but not so much for water. Those are huge to help us, to help the developers have access to the information and see whether or not the strategies that we're working on are being successful. And it's very useful to create culture around our around energy consumption and water consumption. So for the households, it's a useful tool. And then very recently in Colombia, we had like a month ago, a new regulation around energy communities, and there's a very big opportunity there to boost solar powered energy around this regulation. So those were just a couple of ideas I wanted to share with you, and to hopefully that will hopefully be useful as part of your research. Thank you.
Thank you, Clara. I think we are a little bit short on time, and I know the Indonesia team has also some time to, they need to share their stuff. So I'm going to skip this, but in general terms, we're still finalizing the piloting. We're starting all the preparation for the main phase, and we are hoping to start data collection on July 10th. Thank you again, and please, Indonesia team, go ahead.
Hi, everyone. I'm aware that we've got 15 minutes left and 2 more presentations and 20 minutes of Q&A left. I don't think we can fit all that in that time. So
we have the Q&A a bit shorter. I think there are just a couple of questions in the chat for now, which I think we can answer in a couple of minutes at the end. So my suggestion would be that you take, 8 to 10 minutes for Indonesia. Is that feasible? Let's say 10 minutes, and another 8 minutes for the embodied carbon study. Go a little bit over time with Q&A. Does that work?
Yeah. I'm unable to share my screen, unfortunately. Elaine, are you able to share your screen? Share the slides? Yeah, that's great. Next slide, please. Yeah, I mean, I'll try to go through this really very quickly, considering we've got very little time. And I won't really do this the justice that it deserves. This is all credit to Elaine Bakri Putra, who put these slides together, and he's the key sort of person on the ground in Indonesia. It's just very late for him at the moment, so I said that I would present. Just a couple of points of context from Indonesia perspective. Sort of Electricity supply is a vertically integrated sort of monopoly from PLN, a state-owned company. Electricity generation, it's coal dominated, but I think useful to say that they have quite aggressive targets to phase that out and to build something like 75 gigawatts of renewables over the next 15 years. Electricity is actually quite cheap, and the bottom left, it kind of shows how it's the various costs for the different capacities that you can get. I think the reason I say this is that energy efficiency is something that is a priority, it seems, sort of at the government level, and then sort of niche parts of society, the more wealthy sections, and that's sort of reflected in the distribution of edge buildings that we'll see later. Next slide, please. There's several different types of green building certification in Indonesia. Edge is sort of one of them. It's one of the most popular. Yeah, I mean, relatively small share of buildings that are green certified, but there's a big push on really for that. There's general sort of undersupply of housing, and there's a green affordable housing program that's underway to build 1 million green affordable housing units by 2030. Yeah, next slide, please. Yeah, and let's go to the next slide as well. The edge buildings that we're looking to study, they're distributed around Indonesia, but a lot of them are in Jakarta, and for sort of convenience sake, we're mainly focused on edge buildings in Jakarta. Next slide, please. This is what I was saying. If you look at sort of where the edge certified buildings are sort of being installed, you see the sort of bipolar distribution with lots in sort of lower income areas, and then sort of a spike over in the upper sort of middle side of things. I mean, one of the things, so we're sort of, when we're recruiting and sampling, or designing our sample, we're stratifying on the income levels. We think that's important. And on the right is just to sort of say that there's this quite sort of big classification distinction in housing between sort of landed houses and vertical housing, so apartments. And so we've also sort of stratified on that housing type when it comes to our final sample design. Next slide. And yeah, next slide, please. We are collecting similar data to everyone else, as you might expect. So I don't think I'll go into this in much detail. We've already talked about the types of data that we're collecting. Next slide. Yeah, I mean, smart meters, obviously this is about smart meters. There are no smart meters in Indonesia, or maybe just a very small number. So we thought that was a bit of a deal breaker, but in the end, sort of we found sort of solutions to that. A lot of the meters are, as I said, PLN. It's that vertically integrated monopoly. Sort of most houses, use PLN meters. And the good news is that PLN is very diligent about sending manual meter readings, and so actually, the meters are read on a monthly basis, and there's a way that we can sort of gain access to that data via a sort of a public access app, which is great. But there are other types of meters that we're encountering specifically to do with sort of apartment buildings, and so we've had to come up with some solutions for that. So let's move on. Gear line. Yeah, so we have to really go down the manual meter reading route, which is not ideal, but it's something that we've tried out in the pilot. The way we've kind of gone for this is where we can't access the data through this sort of online app, we are simply sort of getting enumerators to take photos. So not rocket science, but if you go to the next slide, I mean, one of the interesting things that Geerlang in particular has been pioneering here is using AI, using large language models to essentially parse the thousands of photos that were of meters that we're going to be collecting in order to extract the information that we want. We want the meter reading, we want the ID, we want the timestamp. And so we're sort of able to convert images into tabular data, and Geerlang's had really quite a lot of success in this. So this is quite interesting, and we think it might be a way of sort of saving time. Yep, thank you, Geerlang. Next slide. We've obviously been piloting out response rates, and we've been doing essentially face-to-face data collection or face-to-face recruitment. We have tried some sort of push to online. That didn't really work in the Indonesian context, and so we're really going to well, this is a lesson learned to be relying heavily on face-to-face recruitment in the main phase. Next slide, please. We've got some, some preliminary analyses of the energy data and survey data that we've collected for the pilot. We've recruited units from EDGE certified and non-EDGE certified projects that are sort of relatively comparable. I mean, what's interesting here is that the EDGE one seems to be using more electricity, and this is where the importance of contextual information is key, which is that we know, because we of the survey information and the building inspection data, that the EDGE certified project here has higher penetrations of AC, right? And on the left here, I mean, this is from an earlier study. The AC really is, unsurprisingly, a huge contributor of driver of domestic energy consumption, roughly doubling energy use, and so it's really critical for us to account for that. Let's go to the next slide. And actually, again, some interesting results already from the pilot data showing differences in sort of behavior associated with the AC between EDGE and non-EDGE. And basically, we're seeing that sort of non-EDGE buildings are needing to use AC for longer periods and for more times during the day. And in terms of the next slide, just some sort of modeling that Geerlang's been doing has shown that, well, when you compare like for like, when you compare sort of AC to AC, it looks like the EDGE buildings or units are actually using less. So it just kind of goes to show the importance of the contextual information there. Okay, next slide, please. We're also doing installations of sensors, which we've just started off doing that pilot. So more on that later. Let's keep going, Geerlang. Yeah, so it's great to see them actually being installed. This is just, I think, from May 21st. This is from today, so it's quite exciting. Next slide, please. Yeah, keep going. I don't think we've got time to go into all of that.
Yeah, we have reached the end of the slide.
Okay, great. Yeah, so sorry if that was extremely fast, but I wanted to try to save some time for everybody. Thank you.
Yeah.
So happy to go next, but Elaine, I'm conscious of time, and if you'd prefer to skip straight to Q&A now, I'm fine with that.
A couple of minutes, so we can go a little bit over time.
Okay, sure. I'll race through.
Sorry, on the embodied carbon study.
Sure. So hopefully now you can see just slides and no speaker notes. So basically, yeah. So I'm Matt Monroe from Arup, and we're working on a study on the embodied carbon and new building materials. I'm just going to run through some quick sort of technical background and terms, go into the main project drivers, key outputs, go into a little bit more detail on the building materials that are included, an update on timelines and progress, and then kind of highlight the main members of the delivery team. So whole life carbon assessment is a process that basically evaluates the carbon emissions associated with a building throughout its entire life cycle. And as most of you will know, this is made up of operational carbon and embodied carbon. And most of the previous talks have been related to operational, whereas the study focuses on embodied carbon. And embodied carbon is basically the carbon emissions associated with materials and construction processes throughout the building's life cycle. So that's things like production of the materials, transport of those materials to site, construction on site, maintenance and replacement during the building's life, and then disposal of the materials at end of life. So those are the modules that we're focused on for this project. The other key term is life cycle analysis datasets. So these are basically datasets that quantify embodied carbon and energy for a given material in a specific region over its life cycle. So one example might be rebar in the region of North America. Most people are familiar, or a lot of people are familiar with environmental product declarations, and the datasets that we're developing are very similar to EPDs. But they're more general for a given geography, whereas EPDs are really specific to, or generally specific to a certain supplier. And basically, it's these LCA datasets that will allow edge users to estimate the embodied carbon of their buildings in the edge application, and then help to kind of guide procurement decisions to reduce embodied carbon. So these are the four main kind of project drivers. So yeah, robust, high quality data, more lower carbon materials, so focused on bio-based materials like timber and bamboo, and also lower carbon versions of steel and concrete. A really key thing was whole life cycle coverage. Currently in Edge, the data sets cover modules A1 to A3, which is the production of the materials, but we're expanding this out to include the full life cycle, A to C. And then the last piece was geographic coverage, so making sure that we've got coverage of all the different global regions, while accounting for the differences in sort of material production and use in those regions. So the key outputs, embodied carbon and energy LCA datasets, like I said, covering modules A to C, those four main material groups for all the different global regions. The second piece is a method and findings report, which basically talks about how we've developed those LCAs. The third thing is training materials for edge users on basically how to include these less carbon intensive structural materials on their projects, and generally how to reduce embodied carbon. And then lastly, new structural assemblies that will be sort of available for users to select in Edge, covering all the new materials that we're researching, plus substructure, which isn't currently part of the application. As I said, these are the four main material groups. Obviously, concrete and steel are the most important or highest emitting and most used materials currently used globally, but timber and bamboo can be lower carbon, so they're also included in the study. And this goes into a bit more detail about specifically which materials in these groups are included. And you can see for concrete, we've got sort of ordinary Portland cement-based concrete, but also concrete is based on other sort of lower carbon binders like limestone, fly ash, GGBS, calcined clay. For steel and timber, also got commonly used products in the list, and also bamboo for countries where we have been able to get data shared with us from suppliers and where bamboo is commonly used. The sort of key considerations that have driven the selection of these materials, first is, like I said, wide geographic coverage of those most used materials. The plan is also to supersede the existing material datasets that are in Edge, just because they just cover the modules A1 to A3. And then the last key thing, although I won't go into too much detail, we've tried to prevent sort of higher than regional average use of resource constrained materials like GGBS and steel scrap, and instead encourage greater use of lower carbon materials that are abundantly available globally and bio-based. That's quite a technical subject, so happy to take questions on it later if there's interest. yeah, so we're 2 years into halfway through a 2-year program, and project is meant to be completed around end of March next year. And we've got project director, project manager, and project coordinator on the call today. But we've also got a wider team who are helping to deliver the project. So Building Transparency, who are producing most of the product stage data for the project. EBP Chile, who provides sort of Latin America region expertise. Sintali, who are sort of edge certification experts, and Construction LCA, who are providing sort of general product level and building LCA expertise. So that's it from me, and I'll pass back to Elaine now.
Thanks, everyone. Thank you so much. So we've already had a number of questions on the chat. Some of them have been answered already. Thank you very much. So there's been a question on whether smart meters were installed already or were installed through the pilot. So this has been answered by Simon, that the data has been extracted from already existing meters, but some additional monitoring equipment is installed for a subset of unit monitored. I don't know if there's time, maybe one of the research team representatives can talk a little bit more about that. There was a question on meter alterations or sub-metering, and Eoghan has already responded to that for Indonesia, but perhaps be interesting to hear from the other country representatives as well. And there was one question on comparing whether we compare the actual versus the simulated cost beyond the consumption, which I think is very interesting because it's also about cost savings. So perhaps somebody can take this one. There was another question on how to integrate sustainable drainage systems into sustainability metric. That seems a very technical question. I'm not sure if somebody's able to take that on. That's as far as I see what hasn't been answered in the chat yet.
Let me, I guess, give a general answer around this idea or this issue around kind of tampering with the meters and kind of energy theft, essentially, that occur from that. So that's clearly an issue, I think, or a potential issue in all 3 study countries. I would suggest that the sites that we are monitoring, both the edge and the counterfactual sites, because of the, I guess, the kind of configuration of those sites, that it's less likely that meter tampering would happen. We can't rule it out, but these things are in kind of like meter rooms and things like that. They do get checked by kind of site managers quite regularly. I can see that Grant's nodding his head in terms of what's happening in South Africa. So the buildings and the sites that are in this project, I think, are less likely to encounter this kind of meter tampering that certainly does exist more widely. And the other thing to say around this is I also mentioned that we're putting in some additional monitoring in a subset of homes in each study country, and that would highlight if there is kind of any major discrepancies from the kind of normal, the data we're getting from the kind of normal meters to what's going on in the additional meter. So the additional monitoring gives us some other data streams, but it also gives us a sanity check against what's happening with the data we're getting from the normal meters.
If I can add to Simon's answer on smart metering. So in South Africa, smart meters were already installed at all the sites we're going to. So that's nice. In terms of tampering, yes, potentially a very big concern for our sample, because it's blocks of apartments and they each have their own essentially secure perimeter. The actual meters are located outside of the unit, or the part of the meter that controls the electrical flow is located outside the unit and is observable to building managers. So that that lowers the likelihood of tampering. We also receive data from all of those meters, and so we can check for exceptions. So for odd levels, suspiciously low consumption, that we would flag up as part of our routine data cleaning exercise. So that's code driven. Typically, though, tampering with meters to essentially steal is an issue, but it's for freestanding households or where the meter is within the household. The city of Cape Town estimates that they lose 10% of electricity to tampering. So that is the rate out there. Yeah, but not so much a concern for our apartment blocks than our study.
Great, thank you. Would anybody speak to the question of comparing costs versus simulated costs beyond the consumption data?
I think very briefly, we're mainly focusing on energy consumption in this rather than energy costs. That hasn't really been part, we haven't really kind of started looking at tariffs and things like that as part of this study. It doesn't seem like it would really contribute to the main research questions. Although we potentially we could look at it as a kind of secondary or tertiary research question if we ticked off all the others, but it's certainly not part of what we're looking at analysis to answer the main research questions.
Yeah. So again, just to add on, I feel like Simon and I have a good one to act going here. In South Africa, because of the nature, the way in which the data is ingested, comes to us, we get payment data and also pricing data as part and parcel of that exercise. Also, our sample ranges from very poor households, so in sort of social housing and affordable housing, all the way through to rich households. So at least for some of our households, pricing through the budget constraint is a material influence, at least potentially, on consumption. And so we are factoring that in. But as Simon says, that's more by way of a secondary, one of many factors that explain consumption.
Yeah, but it's a good point. It's a good point that you're making, Grant, because costs obviously can contribute to the kind of main bit of analysis, and one of the ways that we account for that in our analysis is to have a kind of stratified sample, if you like, on income level, and that's the same in each of the countries, so that we do have that sort of control factor, if you like, around income and energy costs, even though we're not actually analysing energy costs in its own right.
Great, thank you. So we are 10 minutes over, but I see Monica, you are back. Would you like to maybe do some closing remarks before we finish for the day? If you can unmute.
Yeah, sorry, I can unmute now. Lots of issues today. Yeah, no, just thank you very much, everyone. I don't want to take too much of your time anymore. We are already overrunning. Just wanted to, I wrote in the chat that MAGC is just like a wider program that includes other things. So this is like the focus of this webinar was on the research component, but it also includes like concessional finance and advisory service, country level capacity work, and the development of Edge platform. So there is much more. So this is just embedded in a wider program, but I'll leave it here. I'll leave the details away. But thanks everyone for all the interesting presentation.
Thank you very much. So we are, I think we are 10 minutes over, so that's okay. Thank you very much to all the speakers and the participants. Thanks for your questions. I hope most of them have been answered. I will try to share my screen again briefly because we do have a QR code for the link to provide a brief feedback on the webinar, we would be very pleased. Okay, it doesn't seem to work. Do you see the agenda? Slides. Oh, here we are. Okay, sorry, this did not work. I don't know, Philip, if you may be able to show the QR code. Otherwise, I would suggest the link to the feedback is in the chat. It should take a couple of minutes, and we'd be very thankful for your feedback. Thank you again for our speakers. Thanks for participating.
Thank you, everyone.
Yeah, thank you very much, Elaine, for setting this.
Thank you.
Thanks, everyone.
Thanks. Right.